All right, so we talked earlier about inspection and testing. Now, stages of or testing go through several stages. First, development testing. Second, release testing, and the last is user testing. Now, development testing, the system is tested during development to discover bugs as early as possible. While release testing, we do separate testing through separate testing teams, complete version testing of the system before it is released to the user. And then at the end, user testing, where we allow users or potential users of the system to test the system by themselves. So in development testing, it includes all testing activities that are carried out by the team, the development team. And this is done on several levels. And the levels we see here are the most general one. We call unit testing, where individual program units or modules are tested one by one. For example, if we have a system that has let's say data management module, and then take for example email management module. So unit testing means we test the email management module by its own, and we test the data management module by itself. Component testing is a higher level of unit testing, where we test several individual units that are integrated with each other to create one component. So the testing would cover the interconnection between a group of units. System testing, however, it's a testing activity that happens on all the components of in the system, and we test the integration of those components. System testing should focus on testing components interaction, as it is actually designed to do so. Testing every component by itself is done in the earlier level, component testing. So to dive more on unit testing, it's a process of testing individual units, actually not components, in isolation, and it is to trying to find all defects or errors or bugs inside the unit only, and this is not concerned about the communication with this unit with other units and the result or the error resulted from that communication. It is limited only to the unit contents. And take for example this weather station object interface. I hope you remember we talked about 3 projects that we will take examples from at the very beginning of the course. So in weather station, it has an identifier and it has a group of functionalities: report weather, report status, power save, and so on. So the unit testing would cover only those components that belong to this object. So according to I hope you remember the previous diagram, we said, okay, we build the test cases, then we build test data, and then test results after applying those data on the system, and then the report. So as you can see, we need to define test cases first, for example for the report weather functionality, and then we use state model to identify sequences of the transitions would happen, and then we could build the test cases. You can see shutdown, running, and then shutdown. This is the first test case, and we see how the system would respond and what the result is. Configuring, running, testing. I believe this was presented in a previous diagram in software design. So anyhow, those are called testing cases. Now, in small projects, tests are not, of course, testing in general is time consuming, and because it requires lots of preparation. We prepare the test cases, then we prepare test cases data, and then we apply the data, we collect results, and then we write the report. If we have, let's say, tens of test cases, it is manageable manually. But if we have tens of thousand test cases, it becomes almost impossible to do those test cases or implement those test cases manually. So automated testing is a field where we can automate testing, specifically unit, because we have the unit is the most granular testing level, where we write specifications and a software would run those tests according to this specification. So unit testing frameworks provide generic test classes, and then they can run all of the tests that we implement and report. And some of them have even a graphical user interface, which make the testing even easier. And this applies on automated test components as well. So how do we measure the unit test effectiveness? Where the test cases should actually be used, and it should show the component that we are testing does what it's supposed to do. So if there are defects, these should be revealed in test cases. And this leads us to two types of unit test case. The first of these should reflect normal operation, means it's supposed to behave normally according to the test data. So we try actually to test with proper correct data, and then we expect correct answers. The other kind is we provide actually wrong data, and we try to push the software to its limits and see how does it behave. Take, for example, a system that requires registration, and then you could select your age. You need to identify your age. Now, two tests could evaluate the system behavior on selecting age, for example, or birth date. So if I select a birth date that is logically incorrect, for example, let's say if I select I was born in 2015, the system should automatically not allow me to register according, especially if the system is used mainly by adults or by, for example, teenagers and adults, because 2 years old human being can't register himself. All right, so we could try, according to the first type of unit testing, we could give the correct, for example, age range, let's say 18 years, and we see how does it behave. It should actually the system should not complain, and the registration should be successful. While if we on purpose again give the second kind of unit test, we supply it with, for example, a birth date that reflects that the age is 2 years. If the system allows this, and then this means it failed because the age is too little for a user. All right, I hope you got the picture. So this is the difference between the two types of unit tests and test cases, and this applies on component test and system test. And then we could apply testing strategies. We have two here: partition testing, where we identify groups of input that have common characteristics. For example, all the inputs that require personal data, and all the inputs that require let's say material data. I mean something like this, and then we categorize those. We put them in different partitions. And guideline-based testing, where we use testing guidelines to choose test cases, and normally those guidelines are based on previous experience on testing different systems. Now in partition testing, we input the data and output results should fall into different classes where all members of class are related. So the groups of or the partitions of input does not necessarily belong to the same partition as an output, but they are interrelated, and this interrelationship is something that we discover and confirm through the partition testing. Testing guidelines, however, are test software with sequences which have only a single value, and it uses sequences of different size in different tests. And at the end we derive tests so that the first, middle, and last elements of the sequence are accessed. And let's have a look on general testing guidelines. You can see those. We have 5 general testing guidelines. Choose inputs that force the system to generate all error messages. That's a guideline. Design inputs that cause input buffers to overflow. So we are pushing the system to its limits. Or this guideline is encouraging the testing engineer to produce test cases that would push the system to its limits, and so on. And those guidelines are prepared by experts. Then we talked about unit testing, and then component testing, which is a composite components that made up of several interacting objects, or what we call units. We access the functionality of these objects through defined component interface. So as we have a unit interface, we have component interface as well. And what we mean by interface, according to the object-oriented theory, is what is the accessible, visible functionalities of this component. So this component might have more functionalities, but they are hidden, either to be used privately inside the object or inside the component itself, or they are hidden for some other reason. But then we deal only with the accessible with the component interface. So the interface testing has objectives, which is to detect faults due to interface errors or invalid assumptions about interfaces, such as parameter interfaces, data passed from one method to a procedure, from a method or procedure to another, and shared memory interfaces, which is the block of memories shared between those procedures. Procedural interfaces, which are subsystems encapsulated or infused with other subsystems to create our system. And message passing interfaces. And by the way, interfaces does not refer to graphical user interface. It refers to the how to explain this? Okay, interfaces are actually the accessible points or endpoints for each component, that this component could speak to other component or receive calls from other components. So they are normally methods or procedures that are called interface because they